So for this tutorial, I'm going to be looking at a textbook question. This is from page 294, and it's question number 14. And in this question, we're looking at the situation is we have some surveyors are trying to measure a distance at the far side of a canyon, which is the points X and Y. But they can't physically reach those points to measure them. So what they do is they actually establish some measurements from the near side of the canyon, and those are the points A and B. And for example, they measure the distance between A and B, which is 30 meters. They also measure some angles, and the way they measure those angles is they take sight lines. So imagine looking from A across to X. Sorry, let's use the ruler. A across to X and A across to Y. And that allows them to measure the angle between there to be 31.3 degrees. They also look from B across to X and from B across to Y, and that allows them to measure the angle XBY, which is equal to 18.5 degrees. And what else do they measure? They measure the angle ABX. ABX, which is in this corner, so looking from A, they're able to measure down here. ABX is equal to 25.6 degrees. And they also measure BAY, and that's equal to 27.9 degrees. And keep in mind, our ultimate goal here is we are trying to find this distance XY. So in order to find this distance XY, if I just make use of the four vertices that I have labeled, A, B, X, Y, well, there are two triangles here that contain XY. So let's look at each of those triangles. And so if I look at the triangle XYA, which looks like this, so XY down to A, XYA, I'm trying to find this side, and is there anything else I know from this one? Well, I'm given 31.3 degrees, and that's it. I only have those two pieces of information. I actually do have the angle that corresponds to the side that I want. So that's a good beginning. It's always useful, sine or cosine law, if you have the angles that correspond to the sides, but that's not enough. So let's see, do we have any other information? Well, once again, let's make use of the side XY, because we know that's what we're interested in. And what other triangle could I do there? Well, I could do XBY, so that looks like this. And we're going to find we're in a similar situation with this one. So there's X, and there's Y, and there's B. What do I know in this case? In this case, I know 18.5 degrees in that corner. And once again, I'm interested in that side. So I have the opposite angle to that side, but I don't have any other information. So the question here would be, can I get some other information? Is there any way for me to find out the value of, for example, if I could find out this side and this side, then I would have side, angle, side, and that would let me use the cosine law. Similarly, if I could find this side and this side, I would have side, angle, side, and that would let me use the cosine law. So I need to somehow either find, so if I back off of that, actually I'll leave that in place for now, and so I can find XA and AY, or I can find XB and BY. I only have to do one of these two options, and that should give me enough information to find the side XY, depending on which triangle I use. So I'm just going to go ahead, I'm going to look at this blue option. So I'm going to say, well, how can I find the side XA? So let's see what we have here. And I'll refer to our original triangle. So to find the side XA, what triangles could I form that will let me find the side XA where I have enough information? Well, one of the things I'm going to need is a side length. So I'm going to need this side with 30 in it. So what triangle can I form that has XA in it that has at least one side length? I can't do anything without a side length, and that is this triangle right here. And the only additional piece of work I'm going to have to do with this triangle is I'm actually going to have to figure out what is this angle between here and here. But I can do that easily enough. I'm just adding up those two. So let's go ahead, and that's going to let me find the side XA. So I can find XA. Good. Now, does that give me the side AY? Unfortunately, it does not. So let's backtrack that, just unclutter our diagram. And now let's once again ask ourselves the question with the highlighter. I'll choose a different color. How can I find the side AY? Well, here's the side AY. And in order to find that side AY, I'm probably going to need a triangle that has a side length. And there is the triangle that will let me find the side AY. And I can, once again, I can just use this to find the angle. I can just add those two together. So it can be done. So looks like I'm going to have to solve for different things from different triangles in order to get all the information that I need. So let's start picking that apart one piece at a time. The first one I'm going to do is XAB. So I'll just switch over to this and we'll scroll down a little bit. And so what we're going to do is we are going to use triangle XAB to find, and what did I say I was going to get out of triangle XAB? XAB is going to allow us to find the side XA. So XAB, what does that triangle look like? X to A to B is going to require some straight lines. X to A to B, and then B back to X. So that's XAB. So I'll go ahead and label that one. XAB. We chose this one because it had a side length of 30 here. In the bottom corner here, the angle ABX, I believe we know that. If we look back at our diagram, ABX is 25.6 degrees. 25.6 degrees there. In the other corner, XAB, we're actually going to have to take the sum of these two angles. We're going to have to take the sum of these two angles. And so if you add those together, so 31.3 plus 27.9 degrees. If I take the sum of those, I end up with an angle of 59.2 degrees. So that value is going to go right here, 59.2 degrees. And now I take a look, and what do I have? I have angle, side, angle. And I'm trying to use this to find, I'd like to find the side XA. Now, that actually is not going to get me the side XA. When I do sine law or cosine law, I'm almost always going to be interested in corresponding sides and angles. So if I want the side XA, here's the angle 25.6 degrees. I probably want to also have the angle across from the side that I know. So I'm actually going to have to figure out this angle, in this case the angle X, but that's simple angle sum theorem. So we know that the angle X plus 59.2 degrees plus 25.6 degrees is equal to 180 degrees. And so from there we get the angle X is equal to, and I'm not going to take any chances here. Rather than risk doing it in my head and making a mistake, I'm just going to go ahead and use my calculator to figure out that this one is 95.2 degrees. Oh, looks like sorry, let me just erase that. 95.2 degrees. So that is my angle here. Let's put that in. I've calculated this to be 95.2 degrees. So now I'm going to use, I can actually make use of my ratios. I'll use the sine law here, which is that the side XA over the sine of the opposite angle. So XA is here, which means over the sine of 25.6 degrees. That must be equal to, in this case it's going to be the side length of 30 divided by the sine of 95.2 degrees. That means that XA is equal to 30 if I multiply both sides by sine 25.6 degrees divided by the sine of 95.2 degrees, and from that I end up with XA is approximately equal to 30 times the sine of 25.6 divided by the sine of 95.2. And that gives me an answer of 13.0161. 13.0161. So I'm keeping 4 decimal places. That should be sufficient to preserve my whatever level of precision that I need for this question. So now I have found XA. That's one of the things that I need. I need one more thing. I think I'm going to run out of room. Oh, I should be able to get my second triangle in here at least. So what was the other triangle that I was going to use in order to do this? The second triangle that I need to do this is the one that is going to give me the side. We've decided to do this one. So we have just found XA, and now we need to find AY. So which triangle will give us the side AY? That is AYB. So that's the triangle we're going to need now. So let's do that in a different color. Scroll down. And so we're going to use triangle AYB to find, and in this case I just want to double check, I'm going to use that to find AY. So let's go ahead and use the line tool and draw in. There is AY, and there is YB, and there is AB. So there's Y, there's A, there's B. We know some information. We know, for example, this corner, 27.9 degrees, is the same as this corner, 27.9 degrees. We're going to have to do, oh, and we've got 30 meters, so that's constant. And now we have to find this angle ABY. That's going to be the sum of those two existing corner angles right here, 18.5 plus 25.6. So here I have 18.5 degrees plus 25.6 degrees, and that one is equal to 18.5 plus 25.6. That's equal to 44.1 degrees. And now using that, again, I think I'm going to have to do an additional calculation, because here's my side 30. I want the angle across from 30, and I don't have that. And so to calculate that angle is simply to use the angle sum theorem again. So this angle is equal to 180 degrees minus 27.9 degrees minus 44.1 degrees. And that is equal to minus 27.9 degrees. And I believe that is 108 degrees exactly. I'm just going to double check that calculation. 180 minus 27.9 degrees minus 44.1 degrees. It never hurts to double check these things. So yes, 108 degrees. And now I've got my three angles, And so I'm going to form my ratios. Which other side and angle combination will I use? I want AY, so I'm going to use the angle B. I'm solving for AY, so I'm going to write my ratio as AY over the sine of the angle opposite to AY, which is the sine of 44.1 degrees. That's equal to 30 over the sine of the angle opposite to 30, which is this 108 degrees. Sine of 108 degrees. I multiply both sides by sine of 44.1, and that gives me AY isolated on the left, and that's equal to 30 times the sine of 44.1 degrees divided by the sine of 108 degrees. And that gives me my value for AY is approximately equal to, and again, being careful with the calculations, 30 times the sine of 44.1 degrees divided by the sine of 108 degrees. And that gives me an answer of 21.9518. And again, I've rounded that to 4 decimal places. I've sacrificed some precision so that I'm not just writing an endless number of decimal places here. So I'm actually going to make use of the values I have, XA and AY. I now have those two values, and that's going to allow me to calculate what I need. So I think what I'm going to do is I'm going to carry those forward to the next page. So I'm just going to copy these two pieces for now and move on to the next page. So I'm going to be flipping between a couple of pages here. First thing I'm going to do is paste down those calculations that I just made. And the reason I'm doing that is I'm going to make use of them on this page. And I need to flip back and just to verify my diagram. So which triangle was it that I was going to make use of? I was going to use this triangle on the left, which is XAY. So I'm going to use this triangle. You know what? I'm actually going to take a copy of this as well. That's the easiest way to do this. So I will take a copy of that, and once again go to my second page, and I'll paste that in. So that's the information that I'm carrying forward from that page. And just do a little bit of cleanup here. We've got a little bit of some stragglers here. I'm going to get rid of this. Okay. And so now what do we have? Well, we have the value XA, which we've picked up from here. So that's 13.0161. 13.0161. We have the angle, I'm just going to clean this up. This was the angle 31.3 degrees in the corner, 31.3 degrees. And we have this side length AY is 21.9518. Of course, that's approximate. Actually, these are all approximate values. Oh no, they weren't up until that point. Sorry, my mistake. So now I have side angle side, and I'm going to use that to find a third side. That's going to use the cosine law. And so now I'm on my last step, which is I'll use the cosine law to find this. So I will basically say that the side xy squared is equal to the sum of the squares of the other two sides, so 13 point, and this is approximate, I'm using approximate values, 0161 squared plus 21.9518 squared minus 2 times 13.0161 times 21.9518 times the cosine of the angle, 31.3 degrees. And you can see I've already run out of room here. So what I need to do is just get rid of some of this clutter. cut those out of there. Now we can focus just on our calculation. And so from this, if you want to do the intermediate step, xy squared is equal to, make sure you're careful about order of operations on your calculator. So easy for something to go wrong here. I would recommend you actually do this calculation twice when you're ever doing it for yourself. So 13.0161 and square that, plus 21.9518, square that, minus 2 times 13.0161 times 21.9518 times the cosine of 31.3. And I ended up getting for that 163.0168. Now in this case, I'm not going to bother using this rounded value. I'm going to keep all those digits in my calculator, and from there I take the square root of both sides, and so the square root of that answer is equal to 12.7678. 12.7678. Now, to be honest with you, my answer is not that precise because I've been rounding everything to 4 decimal places. So surely I have lost some of my precision. Probably both of those last 2 digits, maybe even the last 3 digits, are really not any good because I've had these successive rounding errors creeping in. But in this case, I can say that based on the information I've been given, I've been careful with my calculations. Therefore, the distance between x and y, which is what we were asked for, is 12.8, and I can assume, let's see, for the distances that we were measured, 30 meters, so that distance is actually 12.8 meters. Now, I just paused in our recording there to take a look, and I think I've actually, I may have misread because it might have asked for it to the nearest meter. I checked the solution at the back of the book, and it had 13 meters as the answer. So obviously we've done our math correctly, and there is a little bit of a lesson there, though, which is you always go back and reread the question before you give your final answer to make sure that you're covering all of the data that the question wants. Okay, I hope that was helpful. That was a long one. I'm also going to post the PDF document with this solution, so you can actually, if you want to, you could print it out and just look at the full solution. What I really recommend, though, is that you, as you go through this tutorial, pause it in the appropriate places. Every time you get a new piece of information, you pause it and then you try to work forward from there on your own. Only watch the tutorial to get over parts of the question that you can't do on your own.